All right, so we're going to look at the second method now of applying multiple transformations. In the previous video, we looked at working right on the graph. Now, an advantage of that is that it can often be relatively straightforward if the function works out nicely, but it can also get pretty messy when you're trying to plot all those different points on the graph. So another method that can be less messy on the graph itself is the arrow method. So we'll take a look at that in this video. Again, remember that the first thing that you need to do before you try and apply any of the transformation methods or the multiple transformation methods is you need to factor, so the immediate coefficient of the x is 1, as we've done here, and again list all the transformations as we did previously. Now, the arrow method actually takes each individual point, and I'm going to start, just as an example, I'm going to use the point -2, -4, and it takes it through each of the individual transformations. Now you would need to do this for each of the major points. In this case, there are 5 of them on this graph. So an advantage to this is that it's a little neater on the graph. A disadvantage is that it can require a bit more writing. So what do I mean by that? Well, again, remember that this order that we have them listed in is a fine order to apply the transformation, so we're just going to follow that order. So I would write an arrow like that, and then on top of that I'd write what transformation is applied. So we start from the original point -2, -4, and we do a vertical reflection. So what's a vertical reflection going to do to the point? Well, it's not going to touch the x value, so the x value is going to stay the same, but it's going to flip it upside down, which means the y value is now going to be changed in sign. So it's going to go from -4 to +4. So we've applied now the first transformation. We've applied the vertical reflection. Now, after the vertical reflection, we can apply our horizontal stretch of factor 1/2. So a horizontal stretch of factor 1/2, well, that's not going to change the y value. It's only going to change the x value. So the y value is going to stay the same at 4, but the x value is going to get halved. So that's going to become -1. So you're halving the x value. Now, after that, we can apply our horizontal translation, that is going to the left 1. So horizontal translation left 1 is going to take -1, move it left 1 to -2, and it's not going to change the y value. Now, lastly, we've got a vertical translation up 3, and you'll see that I write my transformations in shorthand over and above, above and below rather, the arrows, so I know what I'm doing. And then a vertical translation up 3, not going to change the x value, but is going to change the y value. Add 3 to it and make it 7. So now my original point, -2, -4, has now become its image point, or the new point in the transformed function, -2, 7. So this point over here, which was -2, -4, is now -2, +7 over here. And I would repeat that for the other points. So as you can see, at the end, I'm only going to have 5 points on my new graph, so it's going to be nice and neat, although it does require a little bit of work over here. Now, just to show you, if we go back to our original graph before, here is that point here, the -2, -7. So we arrived at the same point, the image of this one down here, in 2 different ways. This way we were working directly on the graph. Here we got the same thing by doing the work over on the side and then just plotting it on the graph. Okay, so those are 2 different methods, and I'll show you a third method in the next video. Oh, and just to remind you, you then need to go and do the same with all the other points here. But I think that was pretty obvious.